So the question is an electric bulb of 60 watt. So power is equals to 60 watt is used for 10 hours daily. So the time duration which has been used is 10 hours. So now they are asking, what is the units of energy consumed? Units of energy consumed by the bulb in a day they are asking. So what their units means what they are asking? Energy, how much it is consumed. So we all knows that energy is equals to what is the formula? First, power is equals to energy by time. Now energy is equals to power into time. So what is the power? 60 watt. But is it possible to substitute watts? Anybody? If you take energy, power always must be calculated in what? Everyone? Kilowatt. Correct? So 1 kilowatt is equals to, we all know, 1000 watts. And 1 watt is equals to how many kilowatts? Everybody? Not responding, you can leave from the meeting. No issues.
1 by 1000 kilowatt.
So 60 into 1 by 1000 kilowatt into time must be in hours. So already time is in hours, which is what? 10 hours. So now 0, 0 cancel and another here 0, 0 get cancel, which equals to 6 into 1, 6 divided by 10 kilowatt hour. So 6 by 10 means I will write 0.6 kilowatt hour. Is it right, everybody? All of you? That's the answer. So I have given you the four options. Option A, 0.06. Option B, 0.6. Option C, 6. And option D is 60. So what is the correct answer? 0.6. So solve it, everyone. Not solved, solve again. Any doubt you can ask. Yes, please. Clear, all of you? Next
Yes,
question,
sir.
right? A weightlifter lifts a load of. A weightlifter lifts a load of. A weightlifter lifts a load of. This is purely numericals, right? So a weightlifter lifts a load of 220 kg. 220 kg. A weightlifter lifts a load of 220 kg to a height of 2.2 meters. To a height of 2.2 meters. Calculate the potential energy of the load. Calculate the potential energy of the load in kilojoules. Calculate the potential energy of the load in kilojoules. In kilojoules. Do you understand, everybody? We have to calculate the potential energy in what, everybody?
In kilojoules.
Kilojoules. So a load of 220 kg. So mass is equals to how much? 220 kg and lifting a height which is equals to 2.2 meters. So now they are asking potential energy in kilojoules. So what is the potential energy in kilojoules? Potential energy in kilojoules, what is the formula? mgh. Understanding? So mass is how much? Mass is how much? 220 kg. G value how much, Ra? 10 meter per second square. H value is how much, Ra? 2.2 meters.
2.2 meters.
Okay. See, units also why I'm writing. You all should know units very well. That's the reason. So 220, 10 into 2.2, I will write it 22. So 220 into 22 kilogram meter into meter, meter square per second square. So kilogram meter square per second square is equals to something. What is that, everybody?
Joules.
Which is equals to joule. Okay, so that's all. So write it, everybody. So 22 0 into 22. So joules. So anybody answer, please?
4,840.
Yeah. 22, 22. See, very simple. No need to worry. So
4,846.
22 square means 484. Understand? So 4840. 4840 joules. But we want in what actually? Kilojoules. So we all know kilo means. What is that? All of you? Kilo means what?
440 divided by 1000.
440. Yeah. So 1 kilojoule is equals to 1000 joules. Now 1 joule is equals to how many kilojoules? 1 by 1000 kilojoules.
5,000 kilojoules.
I'll write 4840 into 1 by 1000 kilojoules. So 1000 means decimal will go how many digits before? 3 digits before. So answer is 4.840 kilojoules. That's all is the answer. Any doubt, anybody can ask. Do it fast, everybody. Clear, everyone? Understand? All of you? Yes, please. Everybody? So anybody having any doubt, you can ask me. Yes, please respond, guys. Completed?
Yes, sir.
Yes,
sir.
Next. Next one. Write the question. The velocity of a body becomes half. The velocity of a body becomes half. Velocity of a body becomes half of its original velocity. Of its original velocity. Of its original velocity. Keeping its mass constant. Keeping its mass constant. Keeping its mass constant. Will the kinetic energy of the body increases or decreases? Will the kinetic energy of the body increases or decreases? And by how much? And by how much? That is what they are asking. If it is increases, how much? If it is decreases, how much? That is what you have to find it. Anybody? First increases or decreases, so that you tell me.
Increases.
Increases. Wow. Okay. Super. Great. Next. Velocity decreases becomes velocity become half means, do you think that kinetic energy increases? What is the first kinetic energy formula சொல்லுங்க எல்லாமே? What is the kinetic energy formula? Sam? Yes, please. What is the kinetic energy formula? Half mv square. Kinetic energy is directly proportional to mass. Kinetic energy is directly proportional to square of velocity. Do you remember, girl? Understand? Who said that increases? Clear? So
Yes.
velocity become half. So what will happen to the kinetic energy, how much it is they are asking. So let me consider this is the initial case, case number 1. Now they are saying mass remains constant and the velocity becomes half of its original velocity. Means V become V by 2. Any problem for anybody? Yes, please. All of you. Now, what is the new kinetic energy? So let me take this is EK1 and this is EK2, which is equals to half into M into V become V by 2 whole square. So which is equals to half into M into V square by 2 square 4. So I will bring that 1 by 4 front. Remaining I will write half into M into V square. So half into M into V square is equals to EK1. So what is the final kinetic energy? Everybody? What is the final kinetic energy? All of you. EK1 divided by 4 means initial kinetic energy becomes half. That's what 4 times it is reduced. So 1 by 4 it will become 1 by 4 times of EK1. That is the answer. So that I'll inform Sam. First focus on the class Ra. So EK1 divided by 4. Do you all understand, everybody? Yes? Please respond. Now, but
Yes,
this
sir.
is not your answer. Anybody can tell? Why, sir, this is not your answer? Question, all of you read once again. What is the question I'm saying? Question, all of you read. If I have written the question, read once again. Question, please. What is the question? All of you read. Shall we stop the class? I'm asking what is the question? Decreases or increases by how much they are asking. So you cannot say decreases or increases. How much they are asking? How much it is decreases? Of course, we are seeing kinetic energy become, the final kinetic energy become 4 times of, like decreases 4 times of initial kinetic energy. So how much is the loss? Anybody can tell? Initially you are having EK1. Now finally you got it EK1 divided by 4. So what is the loss of energy? Anybody? Decreases by how much remaining?
4.
4. So what is this? Anyone? Decreases by how many? How much times? 3 by 4 times. How means? Finally, you got EK1 is, for example, imagine initially you are having an answer, kinetic energy is, for example, you are having 40 joules kinetic energy. So now final kinetic energy become 40 divided by 4, which is equals to 10 joules. What is the loss of energy? Decreases by how much? How much it is decreases? From 40 to 10, how much it is decreases? Everybody. 30 joules. So same way, initial kinetic energy for you is EK1. Final kinetic energy is EK1 by 4. So how much it is decreases? EK1 minus EK1 divided by 4 is the decreased percentage. So how much it is decreases? LCM 4. So 4 EK1 minus EK1 divided by 4. So 4 minus EK1, it will become 3 EK1 divided by 4, which is equals to 3 by 4 times of EK1. Understand, Mr. Lingesh? So answer is decreased by, how much it is decreased? Everybody? Decreased by 3 by 4 times of the original kinetic energy. That is what initial kinetic energy. That is what is answered. I hope you all clear, everybody. They are not asking calculate the new kinetic energy. They are asking increase or decrease by how much. So you have to show that variation. So how much it is decreases, either decreasing means How much it is increasing? It is increasing. How much it is? That is what you have to do it. Okay, everybody, clear? All of you? So neatly solved. So very, very important question it is. So everybody will stop the answer by here. So by stopping here, you are not going to get full mark. They are not asking what is the change in kinetic energy. What is the new kinetic energy? They are asking how much it is increasing or decreasing. If you are saying if it is increasing, how much? If it is decreasing, how much? That is what they are asking. So what is the answer? You have to do it increasing or decreasing. You have to do it initial kinetic energy minus final kinetic energy. So if you do that, you will get the answer. Do it fast, everybody. So decreases means, for example, increases means what will happen? Anybody? Increases means, for example, what will happen? Final kinetic energy minus initial kinetic energy. So if you do that, you will get the increases, because increases means final will be maximum, initial will be minimum. Decreases means initial will be maximum, and final will be minimum. So that is the reason you have to remember. So as we are getting a decreasing here, it will become 1/4 of initial kinetic energy. So initially it is more compared to final. So that's the reason we are doing. It is decreases by 3/4 times of initial kinetic energy. That is what you have to do it. Clear? English? Agalya? Any doubt? Anybody can ask me. Understand, guys? Mr. Gokul Ras, modify the number and join properly. Mr. Jayan, understand? Mari? Nobody is there? Hello?
Yes, sir.
Yeah. Do it fast. Abhiram, understand? Kishore?
Yes, sir.
Hmm.
Yes, sir.
Make it quick, complete it. Pranav Puremara. Right, next question. All of you. So what, right, a car and a bus are moving with the same velocity. A car and a bus are moving with the same velocity. Car and a bus are moving with the same velocity of 40 meter per second. Mr. Prudvi and Sam, you have to answer this question. 40 meter per second. If the ratios of their masses is 1:3. If the ratios of their masses is 1:3, very, very important question. If the ratios of their masses is 1:3, again I'm saying the question, a car and a bus are moving with the same velocity of, 40 meter per second, 40 meter per second. A car and a bus of same velocity is moving with 40 meter per second, 40 meter per second, 40 meter per second. If the ratio of their masses is 1:3, if the ratio of their masses is 1:3, so both there is a car, okay, and there is a bus. The Mari solving there is a bus.
Yes, sir.
So both are moving with the same velocity, 40 meter per second, 40 meter per second. What I will say is, always the good student in physics always goes free body diagrams, FBD. So if you make FBDs, always you can try to solve the question easily. And they're giving what is the mass ratios, everybody? Mass ratio, mass of a car is to mass of a bus is equals to 1:3. Am I right? All of you? Yes, please respond. So what is the kinetic energies they are asking? Means mass of a car divided by mass of a bus is equals to 1/3. So from that I will say mass of a bus is equals to 3 times of mass of a car. Will you all agree with me, everybody? 3 times mass of a car. Yes or no? Please respond.
Yes,
Okay,
sir.
wow.
Yes,
Understand
sir.
pattern? Any doubt in this? Shivani, Darshan, clear? Laksha, Niroshi, clear? So mass of a car, mass of a bus is 3 times of mass of a car. Now they're asking, what is the ratio of their kinetic energies? Answer is 1:3 only. So they're asking how it is, we'll prove it. So they're asking kinetic energy of car is to kinetic energy of bus is how much? So let us take kinetic energy of a car first. So what is the formula? Half m v square. Velocities remains what? Velocities remains what? All of you. Constant.
Same.
Understand? So I am taking. So EK, kinetic energy of a car is equals to half into mass of a car into velocity of a car. What is the velocity of a car? 40 square. Am I right? Equation 1. Next, kinetic energy of a bus is equals to half into mass of a bus into velocity of a bus whole square. Equation 2. So ratio they are asking. So divide both equation. So equation 1 divided by equation 2. So you'll get the answer. Equation 1, half mass of a car into 40 whole square divided by half mass of a bus into 40 whole square. So what else, everybody? 40 square cancel, half and half will get cancelled. So now, kinetic energy of a car divided by kinetic energy of a bus is equals to mass of a car divided by mass of a bus. So just now I had taught you, mass of a bus is equals to, cross multiplication you do, will get it. 3 times of what? Mass of a bus is equals to 3 times of what, everybody? Mass of a bus is
Car.
equals to 3 times of a what? Speak, guys. Mass of
Car.
a car.
3 times of
Over. Mass of a car will get cancelled. What is the answer?
1 is
What is
to
the
3.
answer? Same 1:3. Okay. So kinetic energy of a car is to kinetic energy of a bus is equals to 1:3. Such a beautiful question it is. Very, very important question. Prudvi, Purima, Prudvi, Jai Krishna,
Yes,
Prardhana,
sir.
doing
Yes, sir.
yeah. So such a beautiful question it is. Everyone has to solve neatly. Mr. Mukesh solving Lingesh, Hasini now only are joining. Do it fast, everybody. Make it quick. Okay. Purimara ellame understood. Can display Mr. Nivedan. Okay.
Yes, sir.
Solve fastly. Any doubt anybody can ask? If it is over means then we proceed further. Completed, guys?
Yes, sir.
Hmm.
Yes, sir.
See, the more you solve, more you will get. That's what I'm saying. Okay, right. Next question. How kinetic energy and momentum are related to each other? That is a question. Do it fast. How kinetic energy and, or else, right, calculate the relation between kinetic energy and momentum. That is only the question. Calculate the relation between kinetic energy and momentum. Puriyamara, understand question, everybody? So that's all. As I told you, future, if you go for good universities and all, questions will be like this only. So that's what you have to remember. Purima, so tell me what is the answer? All of you? Anybody? So very simple it is. So what is that momentum? We all know momentum, second chapter we got it. So momentum and power both same symbol. Anybody? So question they are asking, see that how beautiful it is. So how kinetic energy? It's a Jayan solving and momentum are related to each other. Just tell me, Mari, Lingesh, try. Everybody answer. Agalya, Alfin, solving Alfin.
Yes, sir.
Answer, please. Lingesh is saying p square by 2. Okay. So let us see that. We all knows that what is the momentum formula, everybody? From the second chapter, momentum formula. Agalya will say. Momentum formula.
Mass into velocity, sir.
Yeah. Momentum is equals to P is equals to mass into velocity. Yes. Shivani. So P is equals to mass into velocity. Here P means power or velocity. Sorry, power or momentum. Momentum. Okay.
Momentum.
Now we all know kinetic energy. What is the kinetic energy formula? Kavya, half mv square. Okay, wa? Clear, everybody? Please respond. All of you. So now, all of you see that we all knows that momentum is equals to mass into velocity. So that is why to bring it into this format. But here we are having m and v square, it is there. So that's the reason I'm saying mathematics, you can see both numerator and denominator we can multiply and divide with the same number. It remains, our answer is remains constant. Am I right? Maria, understand? Pranav? So to bring the format of same, so both numerator and denominator I am multiplying with the mass. Any problem for anybody? Clear, everyone? So it will turn up into 1 by 2m, 1 by 2m into m square and v square. So now this I will write it 1 by 2m into mv whole square. Any problem? Any problem, guys? Understand? M square is square. So what we can write? A square, B square, I will write as a AB whole square. So now what will happen? MV whole square divided by 2M. So we all knows that MV, mass into velocity, is equals to something. What is that? Mass into velocity is equals to what? Momentum. Understand, everybody? So that is only the kinetic energy equals to square of momentum divided by 2 times of mass. So now from that, momentum is equals to, so P square is equals to EK into 2M, kinetic energy into 2M. So momentum is equals to root over 2M into EK. That is the relation between momentum and kinetic energy, or kinetic energy and momentum. So that is what it is. So if they give even a question can come like momentum is given and mass is given, and they will ask us to calculate the kinetic energy. So you can calculate it or not? Anybody? Yes, please. All of you?
Yes, sir.
Yes. So now, from this beautiful, I will say you, such a beautiful question will form after that. What is the kinetic energy and mass relation? Pakrang here. Kinetic energy and mass. According to this, what is the relation? Inversely proportional. Have you checked it, everybody? Yes. Generally, kinetic energy formula. Kinetic energy equals to half mv square. So here kinetic energy and mass relation is directly proportional to each other. Am I right or wrong? Speak, guys. All of you?
Yes, sir.
Understand? So remember, if mass and velocity relation is given, then according to that, kinetic energy is directly proportional to mass. Momentum and mass is given, according to that, kinetic energy is like reciprocal, 1 by mass. Okay? Because both are inversely proportional to each other. That is you have to remember. So now, based upon this, the next question, beautiful question, write it everybody. A light body and a heavy body have the same momentum. Light body and heavy body. Light body and heavy body. Light body and heavy body have the same momentum. Momentum remains what? Momentum remains what? Constant. Do you understand, everybody? Momentum remains constant. Which will have more kinetic energy? Answer is in your screen only. Momentum remains constant. P is if P means momentum, not power. Momentum remains constant. Then what is the relation between kinetic energy and mass? Anybody? What is the relation
Inversely
between kinetic energy and mass? Inversely proportional, because EK is equals to P square divided by mass. So, which will be having more kinetic energy? Lighter body or heavier body?
Sir, lighter body.
Lighter body will have more kinetic energy because both are inversely proportional to each other. So, lighter body has greater kinetic energy. That is what you have to remember. Understand, everybody? All of you? Clear, Mr. Pranav? Yeah. Do it quick. Any doubt till here you can ask. Clear, everybody? Mari?
Yes, sir.
Yes. Now, same question. If kinetic energy and momentum, what is the relation? Kinetic energy and momentum. Kinetic energy is directly proportional to square of momentum. Am I right? Kinetic energy is directly proportional to square of momentum. And momentum and kinetic energy, what is the formula? Momentum is equals to root over 2m into kinetic energy. So, what is the relationship between here momentum and mass? Anybody can tell? What is the relation between momentum and mass? Momentum is directly proportional to square root of mass. Is it right or wrong? Everybody? Speak, guys.
Yes, sir.
Yes or no? All of you?
Yes,
Yes,
sir.
sir.
Yes. So both are directly proportional to each other. Now the question, right? A light body and a heavy body have same kinetic energy. A light body, give pressure to your brain so that you can understand the questions. Simply namesake reading means no use. So this is not a similar questions what you studied till now, what you are going to study also somewhere. So this is all like first time you might be experienced like this. So this is only the future Future in the sense of 11th, 12th and all, the questions will be like this. CBQs. CBQs means in the madrida. So you have to derive the relation, you have to find everything and you have to make it. Because they will teach you in momentum in second chapter, kinetic energy in fourth chapter. Now they are asking find the relation between that. So that's your duty to have to find it. Nowhere book they will specify. Find relation between momentum and kinetic energy. That's not. It's you have to think over it and you have to do it. So light body and heavy body have same kinetic energy. Kinetic energy remains constant. Prema, which will have more momentum? Which will have more momentum? Who is having more momentum? Who will be having more momentum? Heavy body or lighter body? Nivedan? Lingesh? So we all know momentum is equals to root over 2m into kinetic energy. Kinetic energy remains constant. So kinetic energy of both bodies are constant. So that P is equals to root over, P is directly proportional to mass, root over mass, whatever it is. So who is having greater momentum? Lighter body or heavier body? Everybody?
Heavier body.
Right. Yes. Hence, the heavier body has greater momentum. Understand, Hasini, Laksha, Arasini? Greater momentum than the lighter body. Okay, guys, everybody? Clear? Yes, please.